Good morning, everyone. And today we will learn how to write an equation to represent a function. And of course, we review that. It's not a new lesson. Uh, we have studied before the linear function and the exponential function. To write an equation for the linear function, the general form is y equals mx plus b. Okay. Um, this is the general form. And what is m and what is b? Okay. M is the rate of a change. M is the rate of a change. And b is the initial value or the constant or the starting point. If you want to graph this equation, this is the starting point or the y-intercept point. Okay, so to write a general form or to write an equation for a linear function, you have to know what is the rate of change and what is the initial value. These two, okay? And what is the general form for the exponential function? The general form for the exponential function is y equals a times b power x. Okay. Okay, how can I write the power here? I will try to put it like this. This is power x. Okay, so this is the general form for the exponential function. To write to write an equation for the exponential function, you have to know what is a and what is b. A is the starting point or the initial value. So a is the initial value, and b is the multiplication factor. Okay, you multiply each time to find the next answer. So now you have the initial value and the multiplicative or the multiplication um, factor. Okay, let's see some examples for that. The first example, write an equation to represent this function. First, to write an equation, you have to figure out what is this function. Is it linear or exponential? Okay. Let's see the rate of a change. How is y change and how is x change? Y changed from 4 to 6. It's increased by 2. And x increased by 1. So the rate of a change is the change of x over the change in y. It's 2 divided by 1 equals 2. Okay. The next interval, 6 became 8. Change in y is 2. Change in x is 1. So the rate of a change is the same. The third interval, y changed by 2. X changed by 1. 2 divided by 1 give you the same. So the rate of a change is a constant. That means this is a linear function. Now try to write an equation to represent this function. Y equals mx plus b. This is the general form. Sorry, this is equal. Okay. Now we will change. We change m and b. Y equals m is the rate of a change, which is 2 here. X plus b is the initial value. What is the initial value? From this table, the initial value is the value of y when x equals 0. X equals 0 and y equals 4. So this is the initial value. Okay, so to complete this equation, we'll put 4 here. This is the equation for this function. Y equals 2x plus 4. Again, 2 is the rate of change, 4 is the initial value. This is linear. Take an example for an exponential function. How can we figure out that this is exponential, not linear? Okay, y changed in this interval. Y changed by 2, 1 became 3, increased by 2, and x changed by 1. 2 divided by 1 equals 2. So the rate of change for the first interval is 2. Let's see the rate of change for the second one. 3 became 9. It increased by 6, and this increased by 1. Y, change in y divided by change in x, 6 divided by 1 equals 6. So they are not the same. If the rate of change is not constant, so we will try to figure out if it's exponential. Okay. Okay, let me clean this, erase these numbers, and let's think about the multiplication. 1 became 3, so we multiply by 3. And 3 became 9. If you see, it's triple each time. 9 became 27. So it's we multiply by 3 each time. So 3 here is the multiplicative factor. If we multiply by the same number each time, this is exponential function. Okay, right? And equation for the exponential function, y equals a times b 2 power x. Okay, let me add power x here, power x. Okay, now what is a and b? A is the initial value, b is the number we multiply each time, or the factor. The initial value is the value of y when x equals 0, means a equal 1. Let's change a and put 1 instead. So y equals 1 multiplied by b, the factor, 3. And don't forget to put the power. The power is x. Okay, so the power here is x. 1 times 3 power x. We can ignore this one and keep the equation equal y. Y equals 3 power x. Okay, another example. On Monday, a student has $500. On Tuesday, he has $250 remaining. On Wednesday, he is left with $125. Write an equation to represent this scenario. So, what is the initial value here, or the starting point? When we start, x is 0. The function, the value of the function is 500. This is the first value. Okay, then on Tuesday, after 1 day, so x equals 1 here. Okay, what is the function? Equals 250. And the next day means x equals 2. The function is 125. So it became 125. Okay, that means the function is decreasing. If you notice that it's decreasing by half, 500 became 250, 250 became $125, so it decreases by half. Okay, that means we multiply by half each time. So each time we multiply by half. This is the factor, and 500 is the initial value. write an equation to represent this scenario. So y equals, the initial value is 500 multiplied by a factor. The factor here is 1/2. Okay, 1/2 to the x power. Let's put x power here. Remember, if you have a fraction, put it between parentheses. Okay, let me put it between a parentheses, and then put the power x. Okay, let me put the power x. Okay, so the equation is y equals 500 multiplied by 1 over 2 to the x power. So if this is exponential decay, if you remember, we call this function exponential decay. The factor we multiply each time should be a fraction, is less than 1, because it's decreasing. Okay, now I think you remember how to write an equation for a linear function and exponential function, and you remember the general form for both of them. The linear function y equals mx plus uh, mx plus b, and the exponential function y equals a times b power x. If you need any help, let me know. Have a good day. Bye.